Hello, my name is Keziah May, and today I'm going to talk about how I introduced students to structured problem solving. Through this presentation, we're going to talk about the project I did in general, the technologies I used, my approach to this project, the lessons I learned, some statistical data, my conclusions, and how this research will continue. First, the project overview. With graduation right around the corner, applying for jobs became a huge priority for me. But as I started sending out applications, I realized that I was not prepared for technical interviews. There are plenty of practice questions online, but with the interview bar continuously raising, I needed a way to solve more difficult problems easily. So I asked, how do I break a problem into solvable pieces? An idea was born to create an online course that explains how to solve common technical interview questions. Within the Tech4Good research team, another team formed, the Leet Programming Team, and this is the group from 2020. Here's about how the project went. First, we developed a project plan. We talked about the design, how we wanted it to work, and our general workflow. Then we started in. First, we would go to the LeetCode website. We would find technical interview questions, solve the problems. Then we would go to the STEPIC website. We would write lessons describing the many known solutions to those problems and how to understand why they work. Once we had completed writing the lesson, we would go to GitHub and see what lessons our peers had written, and we would review those lessons. That iteration went on and on and on for about 10 weeks. And after the first 10 weeks, I started presenting workshops on these lessons using Zoom. In total, I wrote 27 lessons, reviewed 11 lessons, and presented 8 workshops personally, but the team has done much more. So what technologies were used? There were several technologies used for this project. To highlight a few, LeetCode once again to get the problems, STEPIC was used to host our online course, and C++ is the language that we used to write about all of the solutions, though the explanations are language independent. So what approach was used for this project? To approach this project, I decided to work on objective techniques for problem solving, to explain known solutions, to evaluate those solutions, to optimize them, and to do so using a variety of data structures. So now that we've talked about the approach, let's explain it through action. Here is an example of a problem that's found on LeetCode. This is one that was given during a presentation on Zoom. Given a paragraph and a list of banned words, return the most frequent word that is not in the list of banned words. It is guaranteed that at least one word isn't banned and that the answer is unique. Words in the list of banned words are given in lowercase and free of punctuation. Words in the paragraph are not case sensitive. The answer is in lowercase. Now, if you're anything like myself or the students that I've presented for, this explanation alone could be a bit overwhelming. So let's break it down and understand its components. First, let's look at an example input, an example output, and why this makes sense. So an example input could be, Bob hit a ball, the hit ball flew far after it was hit, and the list of banned words would include the word hit. The output for this example is the word ball. See, although hit is the most common word, hit is a banned word, so we instead return the second most common word, which is ball. Next, we want to see what the parameters of the possible inputs could be. In LeetCode, they often will give you parameters such as the possible lengths of the input paragraph, or the number of words that are banned, or the length of an individual banned word. So now, creating our objective technique for solving problems. The structure that I came up with for solving problems involves listing possible cases, breaking the problem into individual steps, describing the tools that would satisfy each of those steps, And once those tools have been described, identifying the actual tools that exist which would satisfy that description. Then, for the first step, we choose our tool and we start our solution by just solving that first step and testing it. So how would that work for our example problem? First, we list cases, examples of the length of the paragraph, the number of banned words, the length of the banned words, and then other cases, such as where we might find punctuation or how the case of the individual characters might appear. Once we've listed cases, we break the problem into steps. Now, to solve the problem that we talked about, we have to identify all the words in the paragraph. We have to ignore all of the non-alphabetic characters, and there are several other steps included. Once we have broken it into steps, we can describe the tools that satisfy those steps. Here are some descriptions. To identify a word, we need to tokenize strings by separating the string we're given every time we see a space character. Now, to ignore punctuation characters, we'll need to understand whether a character we're looking at is alphabetic or if it's a punctuation character, and the list goes on. Now that we have described the tool, we can actually find the tool that does this. For example, identifying words can be done using the function strtok. It can also be done using a character-wise traversal of isAlpha or ASCII comparison. To ignore punctuation, once again, using strtok, we can insert delimiters that will tell it where to separate the given string. We can also use isAlpha or ASCII comparison, much like the first step, and so forth. Now we have identified tools, so let's look at that first step and let's choose our tool. I chose for this situation the isAlpha function. And now that I've chosen it, I can start my solution by just solving that first step and testing. Here is my partial solution satisfying the first step and ironically the second step as well. And it's been tested, and so I can move on and loop through that technique. The second approach that I outlined was explaining solutions. Now, to explain solutions, I broke each problem into solution steps. And then I broke all of the known solutions into those same solution steps and put names for each of the solutions that were used. That allowed me to compare all of the known solutions by the same criteria as I explained things to students. The next part of my approach was to evaluate code. What you see here is a checkpoint on the STEPIC course, where students have just been given information about a particular solution, and now they're being asked to evaluate that solution in terms of runtime complexity. The fourth approach to this problem-solving structure is optimizing solutions. By figuring out how each of the components affects runtime, we can start to see where the bottlenecks are and reduce our code to the simplest form. The fifth approach was using a variety of data structures to present this to students. On the left, you can see the syllabus for this course, which includes several different data structures, as well as algorithms such as binary search or depth-first search. On the right-hand side, you can see an overview for one particular lesson, where just to solve one problem, several different data structures are used. Now, what lessons did I learn in this process? When I started, I knew that I wanted to solve difficult problems more easily. I thought that I needed to understand the known solutions, but through my research, I discovered that I needed to understand the problem itself. And once I fully understood the problem and was able to break it down, it became very simple to solve that problem. Now for some statistical data. Many third-year students apply in autumn for their first internships. In autumn, we asked 25 third-year UW Bothell CSS students the following. Do you believe your CSS classes have prepared you for technical interviews? That's about half. How would you rate your ability to solve technical interview questions? Here on the left is low confidence, on the right is high confidence. Do you practice solving technical interview questions? Once again, the results were only about half. Next, we asked 7 students who actually participated in the Leet workshops that I presented. Do you think workshops like Leet programming help students prepare for technical interviews? Now, it might be hard to see here, but all of these answers are yes or it depends. Did you find the Leet programming workshops helped you to solve programming problems more easily? Once again, the blue here is yes, and that other color is some problems. Would you like to see the content of these workshops integrated into the 342 curriculum or another CSS class? And all of these answers, once again, are either yes or with some modification. So what conclusions have I drawn from this? I see 2 paths for this research to go. One is through modification of the current CSS curriculum, and another is through continuing a workshop track. For the CSS curriculum, my recommended approach to integrating this would be through either a weekly assignment that asks students not just to solve a problem, but to first break it down into its parts. Another option would be to create a skills course with a limited number of credits. Another option is to offer students incentives for attending related events and activities to encourage them to seek this knowledge themselves. For the workshop track, my suggestion is to separate it into 3 tracks, a sort of beginner, intermediate, and advanced course. The first would start with structured problem solving, much like it was shown in this presentation. The second track would go over common techniques for solving technical interview questions. This could be using 2 pointers or breadth first search. The third would be actual interview practice, learning how to explain your stream of thought as you solve a problem and presenting a difficult problem in front of others. Now, how will this research continue? There are 3 directions that I am currently looking at for this research. One is through the ACM UW Bothell chapter. They currently have workshops called Cracking the Coding Interview, and this could easily be integrated into that workshop track. Also, the Tech4Good group that I mentioned before will be continuing in this research, and presentations will continue next quarter. Also, there is at least one professor that I know of who has already taken this research to add more problem-solving lessons into the CSS curriculum. There were many different courses that helped me with this research, and I'm grateful to each of my professors for giving me the tools to make this possible. I also specifically want to thank my advisor, Professor Yosef Pissan, the Leet Programming Team on Tech4Good, and all of the students that participated in the STEPIC course and in my workshop presentations. I want to thank all of you for watching my presentation and for supporting me in this research. Here is my poster explaining all of the things that we talked about today. I once again thank you for your time, and I hope that you have a wonderful day.